Alrighty, I've got great news for you guys. We're doing 4.5 and there is not a single proof in this lesson. Yes, I know you're excited. So we're talking about isosceles and equilateral triangles. So let's just talk about some vocabulary. So on an isosceles triangle, and remember an isosceles triangle has at least two sides that are congruent. So the angle in between the two congruent sides, written in blue, is called the vertex angle. The two sides that are congruent are called the legs. The base angles are written in purple, and those are the other two angles that are not the vertex angle. And then the base is the side between the base angles. Okay, here's the isosceles triangle theorem. You are going to use this a lot, so please try to memorize it. So if you have an isosceles triangle, so you know that because AC is congruent to BC, then that means angle A is congruent to angle B. So your base angles are congruent. So we're going to be using this a lot whenever we are doing, we're going to be solving for angles, so definitely keep that in mind. So the converse, anytime you see the word converse, that kind of means the opposite. So on the isosceles triangle theorem, we said if the segments, or if it's an isosceles triangle because of the sides, then that means the angles are congruent. This one says if the angles are congruent, then the sides are congruent. So it's just the reverse. Okay. So now let's talk about a corollary. So this is like a theorem. It's another word for theorem, kind of. So a corollary, this one is, as you can see up here, we had 4.3, the isosceles triangle theorem. So this is the corollary to the, oops, I meant to mark that out, to the isosceles triangle theorem. So this is for equilateral. So if a triangle is an equilateral, then the triangle is equiangular. So we kind of talked about this before. So if all three sides are congruent, then that means all three angles are congruent. And then the other one that's the corollary to 4.4 would be if all the angles are congruent, then all the sides are congruent. So that's something else that you need to know and have memorized. Okay, so now let's talk about theorem 4.5. So I'm going to actually have you cross this out and or just ignore it for the moment because we're going to add a little bit more to it because it doesn't explain enough. So I want you to divide this section right here in half, and we're going to kind of put our own notes in there. And I'm going to have you identify pieces of triangles. So just to recap, if we have that's not a very good triangle, draw a triangle, and then I'm going to draw a line through it, and I'll say those two angles are congruent. So what does that mean? Well, that would mean this line right here would be the angle, do you remember the word? Bisector. So that's an angle bisector, and we've talked about that a few times. Okay, let's draw another triangle. Okay, if it goes through the middle and it makes these lines congruent, and it also says it makes a right angle, that would mean that that is a perpendicular bisector. So a perpendicular bisector makes 90-degree angle and then cuts that segment or that side in half into two equal pieces. Okay, let's talk about another one. When you have a triangle and you have a line that goes through it that makes a right angle, it has to make a right angle. This is called the altitude of the triangle. So altitude. Okay, there's another one that I'm going to draw this triangle a little bit different. It's really easy to get altitude and this one confused. So I'm going to draw it something kind of like this. So this one will be a little bit different. This is going to be whenever you go from the vertex and you go to the opposite side, and it cuts the opposite side in half. So it makes two equal segments. This is called the median. Okay, so altitude is when it makes a right angle. It does not, okay, let's write this so we don't forget. Does not have to bisect the side. Okay, it can, but it does not have to bisect and say this is congruent to this. That's not necessarily true. It just has to make a right angle. The median has to bisect the side across from it. Okay, so we've got all that. Now I'm going to give you a theorem now. Okay, so this theorem that it's a little long, so stick with me. We're going to call it the segment in an isosceles triangle theorem. Please make sure you write all of this down. So if a segment drawn from the vertex angle of an isosceles triangle is either an altitude, median, angle bisector, or perpendicular bisector, ... then it is all four. So if you have it has to be on an isosceles triangle only. So if you have an isosceles, let's draw a picture. And if you needed to pause the video to go back and write all that stuff down, please do. So if you have an isosceles triangle, and I know that because of those angles, and if you have any one of these, then all four of these are true. So if I'm going to say, all right, this is going to be, make a right angle. This is going to have three sides. This is going to be an angle bisector, and put that there. Okay, so if this is an angle bisector, which we know it is because it has this piece right here. Those two tell you that it's an angle bisector because it cut that angle into two equal angles. If it has a median, so remember a median has to cut it in half, and it has an altitude, which is the same one on this one, and we know it's an altitude because it makes a right angle. The median and the altitude on this one are the same thing. Or if it has a perpendicular bisector, so that would be this perpendicular bisector, then if it has any one of those four things, then it has all four. That's something that's cool about isosceles triangles. Okay, so now let's do a little bit of math, not too much. Okay, what type of triangle is this? It's an isosceles triangle. So we remember, what did we talk about? The base angles. Which ones are the base angles on this isosceles? Well, it would be this angle and this angle. And we know that base angles are congruent on isosceles triangles only, but they are. So that would mean the measure, so the measure of angle A would have to be 70 degrees because that other one is 70. Okay, so this next one, they're wanting us again to find the measure of angle A. They tell you right there with those arc marks that they're congruent. So angle A also is 53. Easy enough. Okay, the measure of one base angles of an isosceles triangle is 23. What are the measures of the other two angles? So let's draw a picture. I like to draw pictures. So we know it's an isosceles. And they said one of the base angles is 23. That's a 3. So what does the other base angle have to be? Well, it also has to be 23, right? So we know that one. And then now, how do we figure out this one? I'll call it x. Well, your rules still matter or apply whenever you have 3 angles of a triangle. The inside angles add up to be 180. So we're going to have x plus 23 plus 23 is going to equal 180. Go ahead and combine your like terms. So x plus 46 is going to equal 180. Subtract 46 from both sides. So you get x equals 134. So we found that this one is 134 degrees. Okay, so we found the other 2 angles. All right, now this one, what is the value of x? This one's a little bit different. So if we know angle D is x, what does angle F have to also be? Well, it has to also be x. Okay, and how do I know that? It's because it's an isosceles triangle, and those are the base angles. And base angles are congruent only on isosceles triangles. So now I'm going to solve this just like I have been doing. I'm going to add up all of the angles and make them equal 180. So I'm going to have x plus 30 equals 180, of course. Combine your like terms, so that gives you 2x plus 30 equals 180. All right, we need to subtract 30 from both sides. So those cancel, and 2x equals 150. Divide both sides by 2. So you have x equals 75. Easy enough, right? So that is your answer. 2 more left. We can do it. So what is the value of x? Okay, so on this one, we know if that base angle is 42, then this one also has to be 42 degrees. Okay, and is this an isosceles triangle? Yes. Is this a median? Yes. So if it's a median, it's also an altitude. Remember we talked about that theorem we wrote in. So that means on this one, that would be a right angle. So we have a right angle, we have 42 and x, so let's add them all up and make them equal 180. So x plus 90 plus 42 equals 180. Combine your like terms, so x plus 132 equals 180. Subtract 132 from both sides. So x equals, what would that be? 48 degrees. Yeah, perfect. All right, last problem. This one's pretty similar. So it's really similar actually. So I'm going to call this is x, and so that other arc mark tells me that this is also x. And then like we said, if that is the median, so it also is the altitude, and it makes 2 right angles right there. Let me erase this first one I drew, but so that makes a right angle. So now let's solve. So we have x plus 90 plus 54 equals 180. Combine your like terms. X plus 144 equals 180. Subtract 144 from both sides.
None yet.
Oops, sorry. So subtract 144 from both sides. And you get x equals 36 degrees. Okay, that is all for this lesson. Please make sure you wrote down everything I have written down. If you need to go back and rewind and rewatch stuff, please do it. Thank you for watching.